Now I'm going to talk about the proc means and proc univariate. So proc means is doing um, the data summarization, which is basically we compute the descriptive statistic for variables for all observations, or you can just compute descriptive statistic within groups of observation. So proc means you can calculate the descriptive statistics, quantiles, confidence means, and you can identify extreme values and perform the t-test. So let's look at the syntax of the proc means. So proc means as the proc means, and then there's a by. You can specify variables on the by statement, which is the descending order or can be ascending order. So if you want to get the proc means by descending order of this variable, you can specify the variable in this by statement. Or if you say class, specify class statement, you calculate the proc means on each subgroup in this class and use a var statement to only pick up some of the variables to calculate descriptive statistics. So if you run this proc means on just without any options, then you can get the mean, standard deviation, minimum, and maximum for all the variables. So you can get the all the number of subjects, mean, and standard deviation, median, and maximum for all the variables. Notice that the science variable has one missing value, so you can notice that. And if for VR, we can specify which variables we want to calculate the descriptive statistic. So here I specified read, write, math, and science, and SOC, and then we have the proc means result. Only these 5 variables. And so if we want to calculate the sum of the summaries, for example, if you want to calculate number of observations, mean, and standard deviation, then you can specify n, mean, and STD as an option in this after this data statement. So proc means data HS squared with n, mean, standard deviation, means that we only want to get the number of observations, mean, and standard deviation on each variable specified in the VAR statement. So we have the read, write, math, and social science, and SOCST on n, mean, and standard deviation. And then for class statements, so you can specify the subgroups in the analysis. So in this example, we specify class and program type. So we calculate the summaries, n, mean, and standard deviation in each subgroup by this class statement, and with these 5 variables. So in this results, you can see that so we calculate summary measures on each program type. So for example, for read case, there are 105 observations in read and with academic, and its mean is 56 and its standard deviation 9.6. For general, there are 45 observations for read, and mean is the 48.9 and 9.23 for standard deviation, and etc. So this class statement is useful when you want to get the numerical summary on each level of the categorical variable. Proc univariate provides more information than proc means. So it gives the details of the descriptive statistics, histograms, cumulative distribution plots, QQ plot, which is useful to test normality normality on graphically, and the goodness of fit test for variety of distribution, including normal. So if you run this proc univariate, let's run this proc univariate here. And you can see that we have detailed information on mean, observations, sum of observations, variance and kurtosis, skewness, and test per location, mu equals 0. This is basically one sample t-test. So we are testing whether writing score equal to 0 or not. But this test is it's not very useful in our case because it's very difficult to have the writing score to be 0. And this is quantiles and the extreme observations. And then if you want to get without any with nothing, I mean we don't want to, if I don't want to print out the results, and or if I will just get the histogram, and you can specify the histogram statement, and right and the slash the normal, which means that we create the normal curve on here. So, and the no print option does not create any numerical statistics, and it only just creates the histogram of the right and fit it in the normal curve in here. And then it gives the goodness of fit test for normal distribution. So there are 3 tests: Kolmogorov-Shimirov, Cranach-von Mises, Anderson-Darling. And then in this test, there are statistic indicates that. So here the null hypothesis is that we have normal distribution. And alternative hypothesis is that the distribution of the right is not normal. So the p-value is less than 0.05, so we reject the null hypothesis, which means that the distribution of the right is not normal. But I would recommend try not to use this formal testing for goodness fit test for normal distribution. So I'll just recommend just use the QQ plot or the histogram to look at the normality by graphically. So if you use this QQ plot, so we can see normal QQ plot, then the linearity of these plots indicate that they are normally distributed, but it seems that here the lower tail and upper tail there is a problem. So we might suspect that there is an issue in the normality on here. So if it is normal, then they're on this 45-degree line, but it seems that this is right. It does not have that way. There is a curve on this lower tail and upper tail. Okay, so let's look at the proc frequency and proc format on here. So proc frequency is useful to summarize the results in the categorical variables. So you can use a proc freq for one-way frequency table. So I mean frequency table for one variable. And you can also create the two-way, which is the tables for the two categorical variables, or n-way, so n-way tables. So here I will just create the table on gender, and this chi-square means that we calculate the chi-square statistic. So here the chi-square statistic is testing whether they have equal proportion or not. The null hypothesis is that they have the equal proportion. Alternative hypothesis they do not have the equal proportion. And then here the p-value is the greater than 0.05, so we can say that they have the same. So we do not reject the null hypothesis, which means that we are supporting that they have the same proportions. Male and female have same proportions. And then the chi-square is the chi-square statistic, and df is the degrees of freedom. So let's create the two-way tables by gender and program type. Then you specify the tables with gender star program type. Then you get the gender program, the table by the gender and program type. So gender 0 for female with academic is 47 people, female with general is 21, and etc. And then you can get the row proportion and the column proportion here, which means that row proportion is that, so we think that this is 100%, and then each proportion on each in each column in the row, and the column proportion is that, so we have in each column we have proportion for each level of the categorical variable. So we have total, and then we have the proportion for each cell, which is the second line on here. And then we have chi-square and the likelihood ratio chi-square and other statistics, but we usually get this Pearson's chi-square. And then here, the 2x2 table case, we are testing two variables are independent or not. So the null hypothesis is that in this case, gender and program types are independent. Alternative hypothesis is that they are not independent. So here, degrees of freedom is 2, and then the test statistic is 0.0528. And the probability, the p-value from the test is the 0.9739. So p-value is greater than 0.05, so we can say that we do not reject the null hypothesis, which means that the gender and program type are independent. Then you can specify the several options in this proc-freq. So no row means that you do not display the row percentage. Row column is suppress the column percentage, and etc. And you can do facial zigzag test and print chi-square contribution in each cell, where you can calculate Cochran Mental statistics. So you can specify many options here to obtain your desired statistic. So for here the two-way table, so I suppress the column proportion and row proportion and create a two-way table for gender and program type. And then if we run this one, so we can get the, we suppress the cumulative sum, sorry, we suppress the, I think, yeah, cumulative percentage in here, so not the column percentage. So we suppress the column percentage, and you can get this table in here. So you can run that, and you can see the results. And we can have the using the proc format, and then you can specify the format on here. So 0 means the female and 1 means male, and then we can display this the actual meaning of the variable on this table. So if you run this one, and then you specify the format statement with gender FMT, and put a dot. So this gender FMT is we formulated in the proc format, and we specify this formatting on this table by gender FMT and put a dot on here. So if we run this one, and you can see that we have a female, male, and the academic, gender, or vocation, and you can see the this table with the original meanings, female and male here. Okay, so we have looked at the several proc steps, and for more options you can use the help, and you can Google the in the procedure, and you can see the various syntax on here. Okay, then I will discuss more about the proc steps in the next video.